Okay. You guys, I'm going to record this today because this is one of those things that if you don't understand what I mean, you may need to rewatch the video. Yeah. Oh my word. I already said that. You need this. This is the circle, the big circle paper, and you need notes. Okay.
Something about not understanding makes me worried. I want to take a nap.
I actually sat at my desk this morning. I was like, I should have gotten hot chocolate this morning.
We should go to Wesco.
No. Okay. So there is something in trigonometry called the unit circle. And this is, to me, one of the weirdest things in trigonometry because we're absolutely going to relate circles to triangles. Don't seem like they're related, but they are. It would be nice if I showed you the paper. That's why I was like, it's this paper. Why don't you see it? Okay.
No, because we don't have basic.
Yeah. Okay.
Triangles make up a circle.
No. I mean, we had that conversation, but it's a little bit different. So the definition of the unit circle is a circle. This is the unit circle. Definition is a circle with the radius of 1 and center at the origin. Okay, it's a circle with a radius of 1 and center at the origin. So if we pop him on the coordinate plane, he's got the center at the origin, radius of 1. Okay, that's called the unit circle. So the circle that we're going to be filling out is actually a unit circle. You can assume it has a radius of 1. Now, this is where things get weird because we're going to be relating triangles to trigonometry and all that jazz. Okay, so I'm just zooming in so you can see what we're doing here. Okay, so if I go here and I drop a line straight down, what? Unit circle has a radius of 1, center at the origin. You may say it again?
Something at the center of origin.
Unit circle has a radius of 1 and its center at the origin. Okay, so as seen here, right? Center is at the origin, radius is 1. Now, wherever you put the radius, if you take that point where it joins the circle and drop a line straight down, you create a 90-degree angle. And this is where the trigonometry that we've been doing, which is right triangles, joins up with circles. Okay, so it's not the whole pizza slice thing. Okay, just take a deep breath. Okay, take a deep breath. I would like you to listen to me. The things that we are doing are confusing and weird. Okay, so if you do not understand something that I say and you are actually trying to understand the thing, please interrupt. Okay, don't wait till the end because then I will crash out. Don't wait till the end. Stop me right away.
Crash out anyway. I mean, why not have her crash out? She's already in a bad mood for 6 hours.
Okay, now this is one of the most I don't even know what you call it. Like, this is the lamest question I'm going to ask you all year, or it's the lamest answer I'm going to get all year, but we actually use this a lot in math. What's that coordinate point?
Yeah, what one?
This one right here. Nope, because the radius is 1.
0, 1.
Okay, so this is why this is a lame question. And you know what? You can always answer that question with this answer. It's x comma y. Is it not? Because every coordinate point is x comma y.
So basically that was.
Okay, the coordinate point is x, y, because it's just some generic point that we would like to use. Now, we need to know that because we're going to find the length of this side, and we're going to find the length of this side. So let me put, there's my theta in there. I don't know if my pen is good enough. That's theta, okay, out by the origin. Okay, so what's the length of the side that is opposite of theta? It's y.
You're so smart.
It's y.
That is why.
Yep, because isn't that, you can think about this is, the height of this is y. So this is y.
Oh wait, I get it now.
Do you get it? Because that's that coordinate point.
I do, I understand now.
Okay, now
I now understand.
what's the adjacent side? There you go.
I'm so sorry.
Now,
So these marks are not the first.
okay, here's where this gets a little bit weird. I would like you to find the sine of theta, the cosine of theta, the tangent of theta, the cosecant of theta, the secant of theta, and the tangent of theta. They will all be in cotangent. They will all be in terms of x's, y's, and 1's. Okay, if you can't remember what they are, it's on the other side of that sheet.
This is ridiculous.
Okay, what's the sine?
America.
What's the sine of theta?
You. The exercise. Y over 1.
Yeah, Connor and Javon. The sine of theta is y over 1, which we're going to just call y. Because y over 1 is y. Grayson, you and Eli need to stop your conversation. What's the cosine of theta? X over 1, which is x. What's the tangent of theta? Y over x. What's the cosecant of theta? 1 over y. Yep. The secant is 1 over x. And the cotangent is? Okay, now, here's what I want you to know. There are things that we will do in this section of this unit, like that we're constructing this. You do not have to recreate this. I want you to know where it came from, which is this. You don't have to recreate it. That information goes at the bottom of this circle. So do you see this down here? Those go right on there. Okay, so the sine is y. The cosine is x. This is the bottom left, sorry, of the circle page. The tangent is y over x. The cosecant, I don't know why I'm telling you. You have it written down.
Yeah, we can
So I don't remember doing that. Okay.
we would never do such a thing.
Okay, I would like to, real quick, No, I don't want to say that. Not yet. Okay. This is the unit circle. You don't have to look at it. Okay, let me ask you this question. Let me give you a little bit of a why before we go any further. We know, you don't even have to write this down. You know that if you have a right triangle, you can find sine, cosine, and tangent, right? Because you have an opposite, an adjacent, and a hypotenuse. Okay? But I'd like you to use your calculator just a second, and I want you to, you should be in degree mode. I want you to do like the sine of 300. Okay? It is a number and it's negative, so what the heck? There's no right triangle in the world that has a 300-degree angle. So how can you find sines, cosines, and tangents of something that is larger than a 90-degree angle? Okay, that's what we're dealing with here. So where we're going to get to this. Okay, and it requires this circle in order to be able to do it. So then let me ask you this question. Let's say we're also going to be talking about, like, how do you find, don't write this down either. Like, how do you find the sine of 90 degrees? Like, the sine of 90 degrees is, sine is opposite over hypotenuse. What the heck? Those are the same. How does that even work? Okay, so we have a problem. Problem solved by using this guy. So this is the unit circle, which has a radius of, what's his radius? Radius is 1. Radius is 1. So if this is a radius of 1, what is this coordinate point? 1, 0. Write it down. Okay, let's go up to the top. What's that coordinate point? 0, 1. Okay, how about 180 degrees? -1, 0. And then 270 degrees. 0, -1.
How does that work? -0, +1.
Okay, now, if you combine what we have down here with those coordinate points, I could ask you, for example, to find the sine of 0 degrees. Now, I want you to pause a second and say, like a 0 degrees, that's a 0-degree angle right there. It doesn't have an opposite and an adjacent and a hypotenuse. 0 degrees, but it has a sine. And so the way I find the sine of 0 is I look here and I go, oh, the sine is the y value. So the sine of 0 is 0. What's the cosine of 0? 1, because cosine is x. You can read that down at the bottom left. So the coordinate of the x value is 1. The x value of the coordinate. Okay? What is the cosine of 270 degrees then?
0.
Cosine is x. 270 degrees is 0. So the cosine of 270 is 0. How about the sine of 90 degrees? The sine of 90 degrees is 1, because sine is the y value. 90 degrees, y value is 1. Okay? So the reason that these guys, even though they would never fit in a normal triangle, the reason that they have sines, cosines, and tangents is because of this definition down here of sine, cosine, and tangent. Now, what about the tangent of 90 degrees? Nope, don't want to do that one. Hang on. Let's go the tangent of 180 degrees. Tangent of 180.
Undefined.
Nope. There's 0. Look at tangent. Tangent is y over x. So 0 over -1, which is 0. Okay. How about the tangent of 90 degrees? That's undefined because it's 1 over 0. Okay. Do you have any questions right now? Okay. You can, we could also find the other 3, but I don't want to, just because I don't want to. But it's the same thing. You take your 1 and you divide it by the y value to get cosecant. Okay. Now, we are going to, by the end of the lesson, have all of these coordinate points filled in. Okay. So what I want to do is, this is on your paper, but it requires too many flipping over backward and forward. So let me remind you that on a 30, 60, 90 triangle, here would be 1, 2, and the square root of 3. And then this is a 45, 45, 90, which is a 1, 1, square root of 2. Okay? So what I would like you to do, you don't have to write it, you don't have to write anything on your regular paper if you don't want, but I want you to be able to tell me the sine of 30, the cosine of 30, the sine of 60, the cosine of 60, and then the sine of 45 and the cosine of 45. You don't have to know any other ones. If you have your notes from before break, this is also in those notes. So if you're like, oh, I have those, or you could just find the sine of 30.
You don't have to write this down.
You just got to be able to tell me. Okay, we're gonna write down this, but on our paper, so don't write anything down. Okay, what's the sine of 30? 1/2. What's the cosine of 30?
Square root of 3 over 2.
Okay. What's the sine of 60?
Square root of 3 over 2.
Square root of 3 over 2. What's the cosine of 60?
1/2.
Okay. Those are pretty easy. Now, sine of 45 is what?
1 over root of 2, which was square root of 2 over 2.
Right, so remember we have to rationalize those. So square root of 2, square root of 2. This is square root of 2 over 2. What's the cosine of 45?
Square root of 2 over 2.
Say, square root of 2 over 2. Okay. Now,
Oh my god.
Now, we're going to go back here and use this. We're just going to go a little bit in reverse. So the coordinate point for 30 degrees is cosine is x. That's what it says down here. Cosine is x, sine is y. So 30 degrees cosine is square root of 3 over 2. And the sine is 1/2. Okay, 45 is cosine sine. So 45's cosine, those are the same, so it doesn't matter. So square root of 2 over 2, square root of 2 over 2. Okay. Cosine, sine, so 60 degrees is 1/2 square root of 3 over 2. Well, yep, hold on to that thought. Now, questions so far? Okay, now, there's something, well, let me see if you have to know that term. I don't think you have to know the term.
So when do we get this paper?
Oh, yes. I just told you don't have to recreate this. You get this paper on a test. Fully filled out and correct. Because the chance of making a mistake on this is pretty high. So let me ask you this question. 30 degrees is related to what angle in this quadrant? Is quadrant 2 over here? Nope. 150. Okay? Because this is 30 degrees from the horizontal, right? So this guy's also 30 degrees from the horizontal. Yeah, it's a y-axis reflection. So it has the same x and y values, but the x is negative. So this is negative square root of 3 over 2 and 1/2. Okay, so 45 degrees corresponds to what in the second quadrant? 135. The only thing that's different is that his x is negative. So this transfers over to 45. So negative x, positive y. Okay? Which means that 120 relates to 60. What's his coordinate point? Yep, negative 1/2 square root of 3 over 2. Okay, let's jump down to third quadrant. Okay, what's going to happen to each coordinate point? No, actually, they stay the same. They stay the same. They're both negative. There you go. Both are negative. So what first quadrant angle goes with the 210? 30. Correct, because it's 30 degrees from its horizontal. So this is the 30 degree numbers, but both negative. So negative square root of 3 over 2 and negative 1/2. 225 is going to go with what original angle? 45. So same numbers, but both x and y are negative. Okay. 240 goes with what angle? 60. 240 goes with 60. Same numbers, but both are negative. Okay. Now, in this quadrant over here, what's going to happen to our original coordinate points? They never switch. The y goes negative. There you go. The y goes negative. So 300 degrees corresponds to what original? Nope, it's actually 60 because it's 60 degrees from its horizontal. So 60 degrees, but with the y negative. So 1/2 negative square root of 3 over 2. Okay, this guy's going to be, is 315 goes with what? 45. So square root of 2 over 2, and then the y goes negative. And then the last one is 30. So negative, or nope, sorry, not negative. Square root of 3 over 2, negative 1/2. Did you say you think this is dumb? Okay. Thanks for telling me. Okay, now, what this lets you do is find the exact values of any angle on this chart. Okay, which is something like the exact trig values of any angle on this chart, which is something that we do a lot of. Okay, so let me have you think about this. I'd like you to find the sine, let's go, the exact value. No, let me say this. Anytime you see the word exact value, you're getting this guy out. Okay, because this is where you're going to get the exact values from. Okay, let's go the exact value of the sine of 60 degrees. The exact value of the sine of 60 degrees. Okay, so you're putting coordinate points with your information on the bottom. Information on the bottom is like gold to answer these questions. What'd you say? Oh, I didn't hear the 3. I just saw you said square root of 2, and I was like, that's not even on here. Square root of 3 over 2 is correct. Sine is y. That's what it says down here. Sine is y. 60 degrees y value is square root of 3 over 2. So, like, do not panic when you see these. These are not difficult. Okay? How about the cosine of 240 degrees? Ava, do you have a question?
No.
Okay. Oh, okay. It wasn't the chart. It was your triangle. Okay. Cosine of 240 is negative 1/2 because cosine is x value. Here's 240 degrees. His x value is negative 1/2. Okay. How about sine of 5 pi over 3? You just got to find 5 pi over 3.
What was it? Sine?
Sine. Yeah. So the hardest part is figuring out where 5 pi over 3 is. 5 pi over 3 is 300 degrees. Okay. This is why we want those on there, because then you don't have to convert. It's just there. You're like, oh, there's 5 pi over 3. Sine is the y value. So this is negative square root of 3 over 2. Now, let's talk tangent. Okay, and I need you to make sure you're paying attention because we're going to take a little side trip back to fraction math in 5th grade. Okay, so let's do I'll start you out easy, okay? Let's go tangent of 45. Tangent of 45. Yep. Okay, so tangent is y over x, right? So 45 degrees, the y is square root of 2 over 2. The x is square root of 2 over 2. What's that equal to? 1, because the same thing divided by the same thing. Okay, so that's no problem. Tangent, no problem. What?
Let's go off the tangent of 45 and whatever you want over there. What's the 2?
Okay, so tangent is y over x, right?
Yes, whatever.
So y is square root of 2, x square root of 2 over 2. Got it? Okay, so let's try tangent of 30 degrees, though. Okay, now, I'm going to erase the board because I don't really want to do this. Okay, so this is where you should start writing if you're not writing. Okay, here's your review of fraction math. Okay, 30 degrees is y over x, or tangent is y over x. Okay, now, this is called a complex fraction. When you have a fraction within a fraction, whether it's on the top, on the bottom, whatever. But you guys, this is division. This line here is division, y divided by x. So you have to remember how to divide fractions. Okay, to divide fractions, you keep switch, flip. But you have to have the exact value, which means it's got to be in terms of square roots and whatever. Okay, so keep switch flip. So you keep the 1/2, switch to multiplication, and flip this over. So 2 over square root of 3. Okay, so keep the top, switch to division, flip the bottom. Keep switch flip. These 2's cancel because you got one on the top, one on the bottom. This is a 1 over the square root of 3, and you know what you have to do with that.
Square root of 3 over 3.
So square root of 3 over 3 is the correct answer. That's the tangent of 30. That's the exact value. Grayson, question?
Why is the first one not changed?
Because it's key. Keep the first one. So if you don't like keep, switch, flip, then what you do, if you're dividing fractions, you multiply the top by the reciprocal of the bottom. That's how you would say that in pre-calc language. But keep, switch, flip is easier. Okay, so why don't you try
Butterfly band-aids, biscuits.
the tangent of, that's the switch part.
I don't remember how to do fractions. Why do you cancel the twos?
Okay, because you're multiplying by 2 and dividing by 2, which is 1.
I was thinking like band-aid, like you multiply cross.
No, that's only if there's an equal sign. Okay, so let's go tangent 120, please. Tangent 120.
I don't know how to do fractions. Do decimals.
Flip the top and the bottom of the second. I got that. No, it's fine. Switch the sign. From division to multiplication.
Mm-hmm. Got it, Kara?
What am I doing?
Good.
Okay, it's negative then. Okay. Gosh. So that's what I got.
Javon.
Knock it off, man.
We should tell them.
Yeah.
Okay, so tangent of 120, his y is square root of 3 over 2, his x is negative 1/2. So y over x, keep the top, switch to multiplication, flip the bottom. Okay, so you guys, doesn't matter where the negative is, put it with the 1, put it with the 2, doesn't matter. But you end up with negative square root of 3 over 1, but you don't need it.
How do you?
Go ahead.
I'm not even.
It's okay, go ahead.
Why can you cancel a 2 and a negative?
Because I kept the negative. Because what's negative 2 divided by 2? Negative 1. I kept the negative. It's there because it's here.
Oh, wait, well, some of them will always be able to cancel? Yay!
You guys, that's a great question. You should always have something that cancels. Okay? Always have something that cancels.